All right, listeners, you have heard it all from the kids that education is the key. If you want to be a doctor, it is education that will take you up there. If you want to be a nurse, if you want to be a lawyer, whatever profession you want to take, it is only education that is the key. So that means we teachers are very, very important. I don't think any nation should be playing with their teachers, because we handle the keys and we can choose to give you the wrong key to unlock the wrong door. So if you want the right key, please listen to your teachers, pay them well, respect them, and then give them the due promotion, because we handle the keys to the right profession. So like I said, we can give you the wrong key if the right thing is not done. All right, today we are going to look at principle-based instructions versus rote learning. Principle-based instructions versus rote-based learning. What are the two differences? Let's take a definition over here. What is rote learning? Rote learning, also called drills, entails repeating on or emphasizing an instructional message until the learner can easily recall the message or information without difficulty. Again, rote learning, also called drills, entails repeating or emphasizing an instructional message until the learner can easily recall the message or information without difficulty. Rote learning is appropriate at the basic level of education. For example, for teaching alphabets, ABC, or multiplication table, etc. At that level of education, the basic level, it is believed that the cognitive ability of the learner is not developed to enhance understanding of concepts and theories. Hence, the need for rote learning, because you want to emphasize memory versus understanding, because the brain, the cognitive tool, is not developed to be able to understand and analyze. So at this level, teachers should emphasize memory. At this point of education, the focus of the teacher is to instill what? Memory, rather than understanding, for the reason given first. Now let's also look at what is called principle-based instructions. Principle-based instruction is an instructional approach that is based on principles, rules, formulas, etc. Here are some examples of disciplines that are discipline-based, that utilize discipline-based instructions. An example is mathematics. Math employs formulas. Science is a discipline-based, principle-based discipline, because it's also used formulas, principles, and theories. Accounting is an example, because the accountants will agree with me that the principle of basic accounting, of bookkeeping, is that debit the receiver and credit the giver. This is principle. So you cannot do the opposite, or else you are breaking the rule. English too is principle based. Why? Because if you write wrong English, or if you speak wrong English, you are not following the principle. For example, verbs and tenses. You cannot say the children is eating. What? The children is eating. Well, you better not say this in a party, or else everybody will go home and leave you with this kind of English. So that, for that matter, English is also a discipline-based discipline. The same thing can be said for engineering. These are some of the examples of subjects that are based on principle-based teaching. Now let's take a look at some of the disciplines that are not discipline-based. For example, history is not, because history entails presentation of past facts and happenings. Also, geography is a non-principle based, because it deals with presentation of existing facts, etc. Literature is also one. Well, somebody can argue that they are also disciplined with their reasons. But for this class, these are the few examples of discipline-based courses or subjects and non-discipline-based courses. Let's move further. Here we are going to consider an example in discipline-based instruction. And for example, for the teaching of sequence. Okay, so teaching of math sequence, the topic sequence is a discipline-based. And then the rule is x raised to the power plus 1, where n is equal to x raised to the power n plus 1, where n is equal to 2. Now, I have a table here that is incomplete. We have x variables starting from 1, 2, 3, 4, 5, 6. And then at the bottom here is the rule, x raised to the power n plus 1. Now, if a child is supposed to complete this table, for 4, 5, and 6 because it is a principal base, and the principle here, or for that matter the rule here, says x raised to the power n plus 1, where we know the value of n to be 2. So if we are given x, then how do we find x raised to the power n plus 1? So let's see. If x is 1, and then we plug in 1 into the rule, then we have 1 raised to the power 2, which is 1, plus the constant 1 will give us 2. When x is 2, then 2 raised to the power 2 will be 4, plus the constant 1 will give us 5. If x is 3, then 3 raised to the power 2 is 9, plus the constant 1, that gives us 10. Now, okay, the child will understand that, oh, okay, this is a pattern using, you cannot continue this table without using the rule here. So in order to get the value for when x is 4, then you say 4 raised to the power 2 is 16 plus 1. Then that means the value here will be 17. The same thing will be done for 5 and 6. This is an example of a discipline-based instruction. With this, when assignment is given, the child will have to look for the rule and follow the rule to be able to answer the questions. Now, we are going to look at a video that after watching the video, we are going to judge or tell whether the teacher uses the discipline-based or the rote learning. So very soon we will look at take a look at the video. Today we look at square roots. We study about square roots. This sign here means square root of 196. The square root of 196. Because we have talked about square root, it means we are to have a square of this number. Very simple. You say you add 1 plus 9 plus 6. 1 plus 9, 10 plus 6, 16. Very good, 16. Then, because we are looking for the square root of 6, this number, we take away the 2 here, and the 16 take away 2 is what? 14. Which means 14 times 14 will give you 196. All right, so you have heard the teacher. You have heard the teacher teaching squares, and he used what is called a cut corner approach to teach squares to the students. I have not seen the students to know what level of education, but based on their voices, look like basic school, somewhere from P2 or P3 or P4. And the teacher has started introducing square roots in that basic level. How about he wants to blow the heads of the students? But that is not the message. The message is his simple method that he used. Very simple. Very simple. Okay? But will you call his method root method, instructional method, or principle based? Okay? He said, and I'm going to repeat what he said. He said today they are going to take a look at square roots. All at a sudden, bam, square roots. No introduction, no preparation of the children's mind towards this topic, but all of a sudden, bam, let's look at square roots today, class 3. And he said, what is the square root of 196? And he said, you have to add the individual digits of that 3-digit number. So he said 1 plus 9 plus 6 is equal to 16 minus 2 is equal to 14. For that matter, the square root of 196 is 14. Simple and short. What a good teacher. Well, I do agree with his answer, but I don't know whether to agree with his approach, because the question is, what rule is this approach? What is the principle that the child can remember to be able to answer future questions? Does this rule apply to all perfect squares or only a 3-digit perfect square? Let's continue. Now, let's apply his method and look at some examples here. Okay, a 2-digit perfect square. Now, using his method, the square root of 25, we will say 2 plus 5 is equal to 7 minus 2 is equal to 5. Excellent. That is perfect, very shortcut and correct, accurate. Okay, fine. So the square root of 25 is 5. That is correct, using his method. Let's move to another example using the same 2-digit perfect square. Now, the square root of 16, using his method, we will have 1 plus 6 equal to 7. So 7 minus 2 is equal to 5. Now the big question is, the square root of 16, is it 5? Is the square root of 16 5? The answer is no. Okay? The square root of 16 is not 5. It is 4. By using the teacher's method, we are going to arrive at 5, which is wrong. So the question, I'm rolling the question back. Is his teaching method, root learning method, or principle based? Okay? So if you are teaching based on principles, the principles should run throughout the figures, throughout the day, throughout years, unexpired. But if you are using a principle, if you are using a rule, and then you get to a point that you screwed up, you are stagnant, then it is not a principle-based method of teaching. Let's continue with another example. If you think maybe that was not enough to understand. So we are also going to look at the square root of 81 using the teacher's method. So 81, we will have 8 plus 1 equal to 9 minus 2 equal to 7. Another question is the square root of 81 7? Answer is no. Square root of 9, square root of 81 is 9 instead of 7. So again, that is the teacher's method that he just introduced to class 3 or 4 at the basic level. Now, the concern here is, if a teacher gives the children an assignment like find the square root of 81 and the child writes down 7 based on his approach, would he mark the child wrong or not? Because the child is using his approach. Just add the digits and subtract the sum by 2, and your results will give you the square of that. Okay? So remember, the kids say the future of their education is key, and that key is in the hands of teachers. And remember, I also said we teachers can give you the wrong key. Okay? I'm not going to judge this teacher. He's well composed, well dressed, ready to do his job, but we don't know whether he's doing the right thing. Now, the question is stepping in the shoe of the instructor. If you were this instructor, what would you have done? If you were this instructor, what would you have done? Okay, I'm going to jump in. If I were this teacher, I would have first introduced the students to what is called perfect squares. Perfect squares. The student needs to understand what perfect squares are before. In life, we have to scroll before we can walk, before we can run, before we can do competitive athletics. We don't just start running after being born. So we have to go through life processes. The same thing is learning. You don't just jump to the end. So I would have introduced perfect squares. Now, what is a perfect square? A perfect square is a product of a rational number multiplied by itself. Again, a perfect square is a product of a rational number multiplied by itself. The product of a rational number multiplied by itself. Some examples of perfect squares here include 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Yes, you can teach these perfect squares through the root learning approach, because all you need here is for them to remember perfect square, because there's no method of calculating perfect squares. You only have to remember them, like the times table and or the ABC alphabet. Now, next, I would introduce to learners the squares of numbers. For example, 2 square will give you 4, 5 square will give you 25, 9 square will give you 81, etc. So from understanding perfect squares to understanding the squares of numbers. Okay. Now, if for example, I have taken the students through that, and now I want to introduce square roots. And for example, I say, find the square root of 100, find the square root of 144, find the square root of 196. So from 1, the child will fall back to the previous knowledge of what perfect squares are. A perfect square is the product of a rational number multiplied by itself. So the child will begin asking himself or herself, what number would multiply by itself to give him or her 100? Then he will start saying 5 times 5 is 25. No, too far. 6 times 6, 36. 7 times 9, 49. No. 8 times 8, 64. Getting closer. 9 times 9 is 81. No. 10 times 10 is 100. Yes, I got the answer. So this is how the child will fall back to the previous knowledge based on the rule, based on what you already taught him or her previously, to be able to progress in the learning curve. Okay? So that's why there's the difference between a professional teacher and a teacher just, coming in from nowhere. The training is not wasted. We go through professional trainings and we have to teach using professionalism. So this is how the student will have to, go through to be able to understand. So you don't just cut corners, start from somewhere and start saying, oh, today we are going to talk about square roots. So you have to add the sums of their digits and subtract 2, which does not apply to all numbers. We tried, some of them worked, some didn't. So is this teaching a principle-based instruction or root learning? I leave that question for you to answer. Now, what is the policy implication to we teachers in the classroom? My advice, based on what we have heard today, is that for teachers is that please let us be up and running. Let us be updated, because with technology, students even learn from home before coming to the classroom. But the question is, do they all learn the right thing from online? They will learn, some of them will learn garbage and come to the class and challenge you, the teacher. So you, the teacher, must be faster than your student. You already know what they know. You have to know what they already know. So you can stand on your foot and then correct them and teach them the right thing. Because with technology, well, the advantages of technology outweighs the odds, but the odds cannot be eliminated. Let's not forget about that. So students will come in, they will learn garbage from online and bring that to the classroom and pollute themselves and pollute you, the teacher. So you need to know this to be able to be guided by your teaching. Also, to policymakers, educational institutions, schools and colleges, universities, should we allow our standard of education to continue to drop due to bad instructional approach? What would you do? What would you do? This is a question. What would you do? Um, Today we look at square roots. We study about square roots. This sign here means square root of 196. The square root of 196. Because we have talked about square root, it means we are to have a square of this number. Very simple. You say you add 1 plus 9 plus 6. 1 plus 9, 10 plus 6, 16. Very good, 16. Then, because we are looking for the square root of 6, this number, we take away the 2 here, and the 16 take away 2 is what? 14. Which means 14 times 14 will give you 196. All right, that's it. Look at square roots.